We're here at the location of the new elementary school. The building is about 90,000 square feet, two-story. The idea is to keep erosion from occurring on the site and to keep any erosion that does occur, the sediment that comes from that, keep it on site. So the idea is when the inspectors are looking here from the county, what they want to see coming off the site is clean, clear water. They don't want to see any muddy water, any silt leaving the site. So we're looking here at one of our sediment traps. There are 3 that we'll have during construction. The site is kind of cordoned off into different areas, each of which drains to a sediment trap. And you can see, if you pan over here, there's a diversion dike that channels that water into these sediment traps. So when we had our large rain here last week, Friday, the sediment trap actually was full, and all that water since then has infiltrated into the sediment trap. Any overflow will actually breach the stone outlet and then flow down to other controls on the site. So this is another one of our erosion and sediment controls during construction. This feature is called a slope drain. The idea with this feature is that it drains this entire area bordered by the diversion dikes. Water comes into this area, collects, it builds up to a certain point, it filters through, goes down the pipe, down to the bottom and the outlet, and into the county storm system. So along the entire perimeter of the property, we'll have silt fence. So the silt fence itself is porous to water, but it won't let the sediment through. So the water comes through, the silt gets stopped. That's the effectiveness of the silt fence. And you can actually see that we've backed up the silt fence at the very lowest point of the site with stone or riprap, again, to give it a little bit extra holding power for the amount of water and the volume of water that actually comes against the fence. In some locations, you can see we have like a double silt fence. And this is actually super silt fence. You can see that because it's a little beefier than just the wooden stakes. So it can take a little bit more force. But essentially on an area that's graded like this, we're trying to slow down the water before it gets all the way down to the bottom. So this side of the site is one of the most prone to runoff because of the steep grade here. And as a result, in this area of the site, we've actually got 3 different measures of control. We've got the top super silt fence, we've got the bottom super silt fence, and they've actually backed that up with some stone here to even stabilize it more. And then finally, we've got the inlet protection as kind of the last line of defense. We have a wash rack for the trucks. Trucks are meant to stop here, get washed down. All of the mud, sediment, etc. filters through the rack, heads over to this stone screen, goes into the sediment pond. All that sediment, as it's sitting there, gravity does its work, all that sediment filters to the bottom, so you get clean water that overflows and goes off the site. So another means of controlling the erosion and sediment on site is to stabilize any disturbed areas. And you can see here one way we do that is to seed and straw areas that are disturbed. Once that grass takes, it keeps that sediment from running off site. So in summary, all of the erosion and sediment controls that we've gone over today are an attempt by the county to keep clean water flowing off the site and to keep the public waterways free of silt and also free of pollutants. All of these measures are meant to keep everything on site, keep things from going off site and into the public waterway.